The universe is not silent. It is screaming in a frequency too low for human ears, but perfect for the stars. For 15 years, astronomers have turned the Milky Way into a galaxy-sized observatory, monitoring the most precise clocks in existence, millisecond pulsars. These dead stars spin hundreds of times a second, blasting beams of radio waves that sweep across Earth with the regularity of an atomic clock. If space were calm, these ticks would arrive exactly on schedule, down to the nanosecond. But they didn't. In June 2023, the North American Nanohertz Observatory for Gravitational Waves, or NANOGrav, released a dataset that shattered the silence. They found that the pulsars are wobbling. Not just one or two, but all of them, across the entire sky, are experiencing a synchronized jitter. Space-time itself is stretching and squeezing as it passes between us and these cosmic beacons. This is the gravitational wave background, a ceaseless, low-frequency hum that permeates every cubic inch of reality. Until now, the consensus was that this noise came exclusively from the waltz of supermassive black holes, monsters billions of times the mass of our Sun, spiraling toward each other in the centers of merging galaxies. We expected a choir of rumbling giants, but as we analyze the volume and the texture of this hum, a disturbing anomaly has emerged. The signal is louder than our standard models of black hole populations can explain. It is too energetic. The Hellings-Downs correlation pattern confirms it is gravitational in nature, but the intensity suggests that the choir of black holes has a soloist, something primordial, violent, and far older than the stars themselves. We are likely hearing the decay of the Big Bang itself. The spectral shape of this hum aligns uncomfortably well with the theoretical signature of cosmic strings. These are not the subatomic strings of string theory, but macroscopic one-dimensional defects in the vacuum of space. Imagine the universe as a pot of water boiling into steam. As it cools, bubbles form. Where those bubbles meet, the alignment isn't perfect, like cracks forming in a rapidly freezing ice cube or the boundaries between crystals in cooling metal. In the early universe, as gravity and the strong nuclear force separated, the cosmos underwent a phase transition. These transitions left behind scars, topological defects, where the vacuum energy of the dawn of time got trapped in thin, chaotic tubes. These strings stretch across the observable universe, thrashing at the speed of light. When they cross or snap, they don't just break, they release a torrent of gravitational energy. The hum we are detecting might be the sound of these ancient scars vibrating, a relic of the first fraction of a second, proving that the fabric of our reality is not smooth, but fractured. From that spectral glitch in the data, we must confront the physical reality of the object itself. A cosmic string is a fault line in existence, a tube of energy thinner than a proton, yet possessing a density that defies human comprehension. Because these objects retain the potential energy of the symmetry-breaking phase of the early universe, a single kilometer of cosmic string would weigh more than the entire Earth. A segment the length of your thumb would contain the mass of Mount Everest. This is not ordinary matter compressed. It is a wrinkle in the geometry of space, a line where the vacuum is still hot with the energy of creation. And unlike black holes, which are fixed points of doom, cosmic strings are wandering. They whip through the cosmos, creating loops that decay and fire gravitational waves into the void. Consider the terrifying thought experiment of one of these strings intersecting our planet. Because a cosmic string is infinitesimally thin, narrower than an atomic nucleus, it would not crash into Earth like an asteroid. It would slice through it like a razor through smoke. If a string passed through your body, the interaction would be so localized that it would sever the chemical bonds between your atoms. However, the speed of the event, occurring at the speed of light, and the immense interatomic forces binding you together mean you might physically snap back together before you realized you had been cut. You wouldn't feel the slice, but you would feel the space around you warping. A cosmic string creates a unique distortion known as a conical deficit. It doesn't pull objects toward it like a planet does. Instead, it deletes a wedge of space, causing the universe to fold around it. As the string transects Earth, this geometrical suddenness would trigger a gravitational shockwave in its wake. The passage would impart a velocity kick to all matter behind it. Cities would be jolted upwards or sideways at hundreds of miles per hour in an instant as the ground beneath them tried to close the gap in space. The atmosphere would compress into a blind shockwave. Looking up, you would see the sky glitch. Stars would appear twice, creating a double image as light bent around the defect. While the chance of a direct hit is astronomically low, the mere presence of these defects means our solar system is navigating a minefield of invisible, hyperdense wires. The upcoming Laser Interferometer Space Antenna, or LISA, aims to launch into orbit and visually separate the black hole signal from the string signal. If confirmed, we will have proven that our universe is a flawed crystal, a cooling artifact filled with cracks that still hold the fire of the beginning.